A big part of our life is to make decisions in the morning, whether to wake up early, whether to help your parents, to decide what food to eat, or even prior to that, what food to cook, whether to study, to watch the recorded videos, or to continue studying for this semester. So there's a lot of decisions to make every day, and it's very, very important, or else we will not know as to what to do. Part of the decision making that you are going to undertake is on analyzing the situation and what are the possible outcomes of those decisions that you're about to make. So it takes a process. There's a process of as you analyze on things, and we call them the process of logical thinking, uh, and that is reasoning. So we will be talking about mathematical reasoning for this video discussion. So for our learning outcomes, we are going to use different types of reasoning to justify statements and arguments made about mathematics and mathematical concepts. We first define inductive reasoning. So it is actually a process that arrives at a general conclusion and based on the observation of specific examples. So here we have the process of inductive reasoning. So for example, a game show contestant is given the following string of numbers: 1, 2, 4, 5, 7, 8, and 10. So she'll win the prize if she continue the pattern and fill in the 3 blanks. So we have here the 3 blanks. And then you use inductive reasoning to find a correct answer. So this example is taken from the book of Subike of 2019. Okay, so we start by adding 1 in order to get the second number. To get the third number from the second number, we are adding 2. To get the fourth number from the third number, we are adding 1. To get 7 from 5, we are adding 2. And to get 8 from 7, we are adding 1. To get 10 from 8 is we simply add 2. So looking at the pattern, so we add 1, then we add 2, then we add 1 again, then 2, then we add 1 again, then 2. So the pattern will tell us what to do to the next 3 numbers, missing numbers. So we will simply add 1 in order to get the number after 10, and that gives us 11. And to get the number after 11, we are only going to add 2 to 11 in order to get the second missing number, and that gives us 13. And lastly, to get the third missing number from 13, we are simply adding 1, and that gives us 14. So here you go. The last 3 digits, or the last 3 numbers, are 11, 13, and 14. So we have now example 2. You use again inductive reasoning to find the pattern and make a reasonable conjecture for the next 3 numbers by using that pattern. So let's try to see if our pattern is similar to the first number or is it not. So let's try and see. So these are our given numbers. And we have 1, 4, 2, 5, 3, 6, 4, 7, 5. So again, we are going to make use. So if there's inductive reasoning, there's also deductive reasoning. So what's the difference between the two? Inductive and deductive. Deductive reasoning is actually a process that arrives at a conclusion based on previously accepted general statements. So it's based on overall rules, not specific examples. So overall rules, not specific examples. So when that's deductive reasoning. So let's have some examples to apply deductive reasoning. So our first example, in the process, you are going to use inductive reasoning to arrive at a general conclusion. Then you prove it using, you prove the conclusion if it is true by using a deductive reasoning. So this is our given. So first is to pick a number. So picking a number, then you add 50, then multiply by 2, subtract the original number, and then get the result. So for our first number, we have 12. So we picked 12, and then we add 50, 12, and 50. That gives us 62. And then we multiply by 2. That gives us 124. Subtracting the original 12, that gives us 112. So the result is 112. Let's try to have another number, which is 50. So 50, we add 50, that gives us 100. Multiply by 2, then we get 200. Then subtract again by the original number, which is 50, that gives us 150. Now we look at the original number and the result. So as you can see, the result is 100 more than the original number. So that is still part of the solution. That is not yet your whole solution. So we are going to move on to the next part, which is the deduction method. So the deduction approach is we start by picking a an arbitrary number. So any number. So I'm using here the letter A for the letter A. So and then I added 50 based from the given, and then we multiply what we have in the previous expression by 2. So applying distributive property, 2 times a is 2a, and 2 times 50 is 100. So that gives us 2a plus 100, but we need to subtract the original number, which is a. So we have a here. So 2a minus a, because we can only add expressions with the same literal coefficient. So that gives us a plus 100. So that's basically our initial conjecture or theory is correct, that the result will be, or is will always be 100 more than the original number, 100 more than the original number. So that is already your full solution starting from the previous slide. Next, use inductive reasoning. This is example 2 to arrive at a general conclusion. Then prove your conclusion is true by using deductive reasoning. First is you pick a number, add 16, then multiply by 3, add 2, subtract subtract twice the original number, subtract 50, and then give the result. So our solution, again, we pick two numbers because you cannot see, you cannot look at the pattern if you just have only one. So you can have two, three, or more example so that you can see if the pattern works, and you can use deduction method in order to prove if your theory is correct. So first is I have 23. I added 16, that gives us 39, and then multiply by 3, that gives us 117, and then added 2, that's 119, and then that number is subtracted by twice the original. So 23 is the original number, twice of that. Uh, you get the product, subtract by 119, and then that gives us 73. And 73 is subtracted by 50, then the result is 23. So we cannot make conclusion yet because we only have one number. So we moved on to another number. So just pick a random number. 67. So 67 added by 16. And then that gives us 83 multiplied by 3. So that is 249. Added by 2, 251. Then 251 minus twice the original number, and that gives us 117. 117 minus 50, that gives us 67. So our initial conjecture or theory would be that the result will always be equal to the original number. So let's try to see and use deductive method in order to prove that our theory is correct. So when you will be writing it in your paper, you will be writing the initial uh, conjecture, and then make a proof and use again another table to create your proof. So our approach again is deduction. You pick an arbitrary number. Again, I'm using A. I added 16, so I have A plus 16. Multiply by 3, this time it should have a parenthesis because you have a binomial here. And multiplying a monomial and a binomial, that would um, apply the distributive property of multiplication over addition. So that gives us now 3A plus 48. This time we are adding 2, so that gives us 3A plus 50. So 2 can only be added to 48. Because both are numerical expressions, and subtract twice the original, so that's 2a. So 2a can only be subtracted from 3a because they have the same literal coefficient, which is a. So 3a minus 2a is a, and plus 50, and subtract 50. So this one is actually equal to 0 now, which left us with A, and that's the result. So the final answer is always equal to the original number. So our last example is using, again, inductive reasoning to find the pattern for the answers, then use the pattern to guess the result of the final calculation and perform the operation to see if your answer is correct. So you must have the given. Of course, you will have the given in your module. And now we will be applying the computation. So if you would like to write using different colors, that would be much better to give emphasis on what is the given and what is your solution. So I would love seeing colors in your paper. So here, that's the first line is 1 is equal to 1 squared. Of course, 1 times 1 is 1. And here, 1 plus 2 plus 1 is equal to 2 squared. So we have already 2 here, 2. And this part here, that's another 2. So 2 plus 2, or 2 twos. 2 twos is 2 squared, or 2 times 2. So let's try to see in the next given. We have 1 plus 2 plus 3 plus 2 plus 1 is 3 squared. So we have a 3 here. we have a 3, and then we now have 1 plus 2, that's 3, and 2 plus 1 is 3. So let's try to see how many 3's do we have. So we count 1, 2, and 3. So there are 3 3's, and that gives us 3 squared. So 3 plus 3 plus 3, or 3 squared, is the same. So from this pattern, how are we going to um, know our question mark? You can actually do a few more pattern. Um, this is actually called the ellipsis, or it means that there are still some numbers, there are still some expressions in between. But looking at the first two computations, solutions, then it will tell us uh, how to do this one. So we now go to the middle. So go right away to the middle, and that is 7. So we put some patterns. We look for sevens. So our sevens would be 1 and 6, 2 and 5, 3 and 4. Same thing here. 3 and 4. Then we have 5 and 2. And then we have 6 and 1. So how many sevens do we have? That's 7. This is 7. This is 7. That's 7. And that is 7. And that is 7. So how many sevens do we have? 1, 2, 3, 4, 5, 6, 7. So there are 7 sevens, or that gives us 7 squared. 7 times 7, or 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7. So to check if your answer is correct, you just use your calculator to check that 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is equal to 41, and 7 squared is equal to 41. So, with examples that we have discussed, do you think mathematical reasoning would be very helpful to you as you make decisions in your daily life? So that is something that you need to ponder on. So thank you so much for listening. Don't forget to click subscribe and the notification bell so that you will be notified with the new videos that will be posted in my YouTube channel. Thank you so much and have a good day.